Yeah, just a little bit by myself. So I'm a practitioner. I work as a consultant. Königsweg is a boutique consultancy. We enable our clients in data science and AI on multiple levels. So I'm very active in the Python community because, as you see later, it also plays an important part for our company and our company culture. And yeah, so that's the company. That's what we do. Apart from data science, we also advise on strategy and innovation and business transformation. So, how did this talk come about? No. I talk to many people. I talk to clients, like executives, about data science, innovation, and they have many questions on what they should do, what they should move, about the possibilities. And since I'm also very active in the conference community, I talk to many experts as well. Also, when we do projects with experts, I talk to many experts. And I just want to show you a little bit of both sides and what you can do with AI in this talk. So let me start with a story. How to buy AI. Just a few weeks or month ago, I met an old friend at the train station. And she was super excited. Hey, Alex, I'm coming back close to home. I have a new position. She's like a top executive. She was super happy to work for this new company. And she said, hey, we haven't seen each other for a while. So what are you doing? And said, yeah, we basically, I'm a partner of a boutique consultancy for data science and AI. And she said, oh yeah, that's great. In my new job, I have to buy AI. And I was just like thinking, okay, how does one imagine buying AI in 2020? Yeah? Like cut or piece? Or can you just get it off the shelf and buy AI? But I think it's a very good example how we see the perception of AI is basically very wrong in many heads because there's a lot of noise. And I hope after this talk you will be able to a little bit differentiate between the signal and the noise. So what's the public perception of artificial intelligence? I always like to Google that, and we always see this white robot. It's always the same pictures. It's super repetitive. It's actually quite boring. It's always the same. Also, like the coloring is always the same. You can also see what's our future vision for AI. Yeah, it's some thinking white robot again. Is this a real vision? Is it a real future vision? You also see already somebody we will know a bit later, a bit better. So where does it all come from? So let me start earlier. This is Utopia. Of course, many ideas, as you will see, come from television and entertainment nowadays. Our vision of the future is at large scale developed in entertainment. Maybe in the past it was books like Jules Verne. Nowadays it's the movie industry, and this is from the Disney World. And of course, Disney World is also like a big part of entertainment. And you see, this is the future vision, the future city, space travel, green, no climate change, ancient history, pyramids. This is like one Utopia vision. So, and this is why they, for example, in Disney World, like Epcot as a space center. And there was still like this very positive future vision. If you look at the Jetsons from 1962, you always have like a vision of, okay, here's your, yeah, actually that's Ruba nowadays, yeah, now it's like smaller, but you see, yeah, it's like fully automated luxury communism vision for the future, and flying cars, and you see this resonates. People like, oh yeah, there's a startup for flying cars. Everybody gets super excited because we have the ideas in our head already, which is great in one part, but we have to be aware they are just like concepts, and these concepts are just like still entertainment. So one more vision is this. Who knows this? One? Okay, you're buying the next Netflix, you know that? Okay, let me introduce you to HAL. HAL is a supercomputer on a spaceship. And it's a Stanley Kubrick film. It's actually pretty great design. And actually, HAL decides to kill the crew of the spaceship. Wow. And this is one. And this is 1984. I think, who knows that? I think everybody knows Terminator. Yeah, who knows? This is like Arnold Schwarzenegger before he became governor of California. And after he was a bodybuilder, he became an actor. So this was the vision of the next thing. This is a robot killer machine. So in 1984, Skynet, an AI, takes over and decides, oh, let's get rid of our creators, let's get rid of the humans, and machines start to build machines. This is like a dystopic vision of the future. Most visions of the future are that dystopic. So we also have positive things like Star Trek. So let me look. This is Jean-Luc Picard, if you don't know him. And what does he do? He talks to his computer. They always say, computer. And what do you nowadays? You say, oh, Alexa. So the same concept was already in the entertainment decades before we actually had it. We also see these devices here, like a tricorder. I haven't forgotten my phone here. It also, like, if you think about like mobile phones, you could actually open and call. This is like a tricorder. And also we see a real, fully featured actor like Data is like a person in the show, is basically also an artificial intelligence. Yeah. Okay, so artificial intelligence as well is not new. It's actually pretty old. This actually is 1950. So artificial intelligence predates relational databases. They were invented in the 70s. So this is the whole field of artificial intelligence. So if you ever wondered, machine learning was the big thing. If you listened outside, like everybody was, oh, data science, machine learning is the next big thing. And then it suddenly all became artificial intelligence because, of course, it sounds better. It has the word intelligence here, the better sale than machine learning. And this is basically everything is machine learning and artificial intelligence. Machine learning is just part of artificial intelligence. Deep learning with neural nets is also part of machine learning. So it's actually quite simple. Let me show you a little bit more about the history of AI. So AI was always there. So we had like these electronic brains in the 1940s. And then it's also like in the 50s, you can see on YouTube, you can see videos from NASA where they show a computer, a picture of people, and the computer can say, man, woman. So facial recognition back then on black and white pictures. I mean, it was not even color television. So we see like there's like multiple improvements here over time. We also see one big bumper was the XOR problem. It was a very important person in the AI space who published a book and says, okay, we cannot solve this XOR problem. I don't want to go deeper here, but basically after 1970s we had the dark age. It was an AI winter. Basically people gave up on AI because they thought this is not feasible. We're not able to improve this. Only very few people, for example, like Hinton is one of them. You see him here. You see him also here. He was one of the few people who kept on working in the domain. And basically, if you look at like conferences like NeurIPS, which is the biggest artificial intelligence conference in the world with like 8,000 people, the last year's tickets were sold in like 5 minutes. He was an outsider for decades because he still believed in the technology. And then now here in the beginning of in the mid of the 90s, support vector machines were introduced, things were picking up. And you also see another thing happening here probably. What happened here as well? You also see, this is also when the internet happened or started to grow and flourish. And basically also deep neural networks are pretty new for technology. They're just like 15 years old. And some of the neural nets we're looking into are basically just invented 5 years ago. So why did we ever come back from AI winter? So these are the drivers today. So one problem at the time when AI was invented, computational power. The computers had not enough computational power, so it was really small. I mean, at the time when they worked on these computers still filled rooms. When AI was already in the making, the boss of IBM said there's only a market for 5 supercomputers, somewhere in the 60s. So he was probably proven wrong, I guess. So of course, we have a lot of more CPU. I think who knows Moore's law? Who has heard about it? Yeah, okay. Moore's law is actually every 2 years computational power will double. Yeah, it's a rule of thumb. It's not a real law. It's more like a rule of thumb. So we see more computation power. We also see new concepts like using GPUs for computation. For you, if you start in the space, oh yeah, of course you run neural networks on GPUs, but I think, not much more than 10 years ago, somebody made that discovery. Yeah? So this is also not like on GPUs forever. Also now, Google, IBM, Amazon even now, Apple has an own AI chip in an iPhone. So also new hardware is invented to make AI work faster, especially also in application. A big part is also, of course, the access to data. Now, with the internet, we can also store, storing data is super cheap nowadays. I remember maybe, in the middle of the 90s, we at a company, we had people working on neural nets, actually. And I remember when the first 1 gigabyte hard drive arrived, it was 5,000 D-marks at the time. It was, it has 1 gigabyte. This is something you basically love today. What's a gigabyte? I mean, I don't think it's even possible to buy a gigabyte stick anymore, yeah, basically. So storing is cheap. Also, the internet gives us access to great deals of data. So we need, for AI to work, we need a lot of training data. So now we have the data, we have the hardware. We also have to see knowledge is nowadays globalized. So I have access to the latest findings from somebody on the West Coast in the US. Once it's published, once it's on ArchiveX, if there's a blog post, if there's a tutorial, people also, through the internet, academia shares a lot of the knowledge. Yeah? Sometimes it's too much even to process. And also not only access to the latest research and findings, it's also about more access to learning. When I taught myself programming, I had these 2 books. It was very painful, and I had nobody to ask. And nowadays, if I want to learn something new, I can go to one of the conference sites from, for the Python community, always publishes the conference videos. I can go on YouTube, and it's very likely I will find the right person who speaks my language, also understanding each other, how to explain things. It's pretty awesome. Yeah? You can read, you can have video, and people share their knowledge. It's not longer the case you have to go to a library and find the right book. Or they even have, and also software is a big driver. Software used to be closed. Companies, you had to purchase software to program, to make something happen. Now you can just you just need a laptop and you need some skills and you can work with open source software. And the most sophisticated software you can get nowadays for AI and everything is open source. There's not open source, it's not the cheap version actually, you get the real thing from a major vendor. Open source is the leading software technology for AI and data science. So let me give you 2 perspectives. So one is from the data scientist, an AI engineer, and the other is more from the management side. But I think from the management, you have a better understanding already anyway, because you're in a management school, so you should know. So there's a data scientist perspective. And let me start with this. Who knows the Blacklist? Nobody? Okay. Okay. The Blacklist is a TV show, and there's many TV shows where you basically, of course, they are FBI, they're a special FBI investigators team, and they have always this one person in these TV shows, and he can work with computers. And they always go, hey, can you do that? Or we have this emergency. We need to stop the terrorist or the bomb or whatever. And you see this person, oh yeah, I just hacked into this. Oh yeah, I just read the manual, and it all happens in a few seconds. And of course, this is totally wrong. Yeah? You cannot basically do everything in this. This is a lot of work, reading knowledge. I think we saw also in the presentations earlier, yes, of course we have all the tech, but really making the tech work in production is another challenge. Yeah? It's not about the idea. It's not the idea who basically can solve the problem. It's actually bringing it into production is a lot of work. And so even if you think your demo didn't work that well, hey, it's natural. It's totally okay. Don't feel bad about it. how does like a stereotype data scientist, engineer person looks like? Does it look like him? This is main actor from Mr. Robot. Like he's a hacker. Are we looking for hackers? You know, hackers are on TV, almost like going there, you see like a lot of code going on, and they do like fight everything, and it's like a totally wrong perception of programming, because programming is more reading and thinking than actually writing. Is it more like the entrepreneur style? Or is it more like the superstar? Because, you know, apart from being influencer, it's data scientist is the sexiest job of the 21st century, as said. So actually, probably none of them, because actually you always look for people with multiple skill sets. So basically the whole job description is pretty new. Data scientist, the data scientist job title was invented in 2008, so it's pretty new. And we also have to think from a company management side, where do the people come from? Because data scientists and AI engineers, they don't grow on trees. You either can have people from academia transitioning to jobs of data scientists. So we see like many people, especially physicists, they become data scientists because they do the math. They know the math, also mathematicians. You see also many people like lateral entrants, as we say, Seiteneinsteiger in Germany, who just like say, okay, I want to involve in this business, and the knowledge and how to learn it is out there. But there's not like a lot of experts with a lot of production experience. The whole field at this scale is pretty new. So you don't have like oh yeah, I'm a 20-year data scientist experience, you should hire me. This is not possible, it's not there. What are the skill sets of a data scientist, for example? For example, you have data engineering, which is like computer science. So data engineering is also like the most crucial part, because I think in almost every presentation, what was the painful part? Oh yeah, clean data, missing data. So it's not just like, hey, take some data, do some AI or magic to it, and then you have like the knowledge. No, this is the painful part, and this is probably 80% of data science and AI projects is getting the data right. Because actually like the data scientists, they are like, once they have like clean data and they don't have to clean up and mangle it themselves, basically they have a nice job, because they can have like the awesome findings, the great visualizations. They basically can say, as we say, like the cure, like, hey, yes, this is great. And yeah, these are like people who probably are not seen, but also like if you look into like the job market, this is the most paid job currently, not the data scientist. Because accessing the data is still the biggest problem. So also, it's not a technical role. It's not only a technical role, a data scientist. So you have the data engineer with like some core skills, like mangling the data, collecting, managing huge amounts of data, building data architectures. You have the data scientist who is able to program in a language which provides you statistical models and insight, like for example Python or R. And then you also have, and all these people need to also interact and talk to the business stakeholder, because you cannot throw data at people and say, okay, yeah, great findings, this is something. So I really like that, for example, the government is saying, yeah, we have now Gaia X, all the companies share data. And I said, yeah, well, what's the data worth without being able to talk to the domain expert? Anonymized data is not, yeah, well, we will see a little example later. So basically you look for like a quite diverse team of many experts with many skills to make all this work. So it's not like a single person, like it's not one person solving all these problems. So also when talking to many data scientists, they often cannot live up to their full potential. Actually, they're quite frustrated. In big enterprises say, I don't have access to the data. Basically, I'm only working as an analyst. I cannot live up to my full potential. I cannot bring also the maximum value for my company to the table I could, because there are limits. Very often, just like the data is not accessible, nobody knows where the data is, and all these things, or people have not a real understanding what they could provide as value to the company. Yeah, so the manager's perspectives, I think, let's just keep it short, of course, managers spend time on, most of the part is administration, solving problems, strategy, innovation, and developing people skills, but a big part is administration. And if you think about what is the perception of AI for managers, I Googled that as well. We have seen these pictures. It's a little bit different, but what happens if you Google this? Yeah. So there's a lot, of course, if it's top on Google, there's a lot of noise out there. Many people write about it. So this is why this is the first thing. So what is about replacing data scientists? Oh, okay, this is a question. Will AI replace data scientists? Because there's also libraries, models like Otto and L. Yes, we can automate the whole process. We can, a lot of the work a data scientist does, we can automate this. Yes, you can, but this is probably the solution. I also looked into data engineers. So, as that, this is the sweet spot. Yeah, there's a lot of talk going on. This is like from, we recently sponsored an event with Richard David Brecht. He's like a German philosopher, very often on TV. And of course, like the future of work is also a big topic. Many people are afraid to lose jobs, to disappear, that nobody needs them anymore, and all this. And of course, there's a lot of noise from all these providers, especially the cloud providers. Like it's the big fight on the cloud market. Who will provide the AI service, the infrastructure, the technology for the companies? So of course, if somebody invents something new, other companies will just follow promoting it without even having the technology first. If you look at many new projects at cloud providers, like major cloud providers, you basically are using beta software. It's not mature software. So it's a big fight going on. There's a lot of noise. And for a good manager, I think, it's very important to be able to differentiate the signal from the noise. So, of course, people want to sell, so they scream. So there's a lot of like buzzwords, hypes, and promises going on, and you have to tackle all through that and make an educated decision by knowing a little bit more about the technology. So, as end of 80s, Public Enemy said, don't believe the hype. Yeah, don't. We're back. And so part of this lecture is also a part of an education or like a training we provide for companies. So it's called data literacy for managers. So managers can better understand the technology, have a better understanding of what they need, how they should prepare, how things work without the necessity of becoming a programmer. So let me sum up some misperceptions out there. And let me start with the first, which I usually address to data scientists and more the data science or data engineers, because there's a lot of know-how. Like, they're like very smart people. And of course, if you're very smart, you want to share, you probably want to overshare. So the first mistake is don't try to explain everything. So to sum it up, this is the whole data processing pipeline: collection, management, evaluation, data application. What needs like an executive level really know about? Data is being collected, data is being managed, data is being evaluated, and let's look a little bit into data application. These are the only parts you need to know a little bit. Let's look a little bit deeper into data application. In data application, you only need to know about data ethics as a manager and evaluating decisions, because you don't need to know about critical thinking, because the experts are paid for the critical thinking, and you trust your experts, they do this for you. And so there's only few parts you really should know as a manager to work in the field. So if you're an expert, try to stay to the point, because it's always like easier. So this is the major mistake, like many top level executives done. AI, data science, it's not the IT department. It's not at all an IT department. IT department will, of course, operate the technology, but it's not an IT project. It's actually, data science at first is always research and development. So you have to go like with an open mind field. You cannot basically say, solve this problem. You can say, the question is more, can we develop a technology to solve this problem we would like to see. Very likely you will say, we cannot solve this problem, but we found 5 other problems we can solve now for you on the way. So you have to be open. You need some open budget. You cannot just like go like with the classical software. You cannot show, it's not like application software. You can say, okay, we need to put this process into an UI for a company. This is not how things work. You need to be open, and you also need to be open if things don't work in a project, which is, yeah, it's always like a little roller coaster ride on AI projects, but it feels better if you really solve the problem. So also another mistake is, yeah, it's data. Data is truth, and data is unbiased. Data is very biased. Sometimes you hear about people like, for example, like the police in the US now has an AI system to suggest if they should like stop somebody in a car, and it's definitely biased on black people. This is something you have to be aware of. It's like a big ethical challenges because the AI systems, they don't learn as we humans do. They don't have morality. They don't reason about things. They just learn on the data which is there. So basically, if you discriminate one group, you basically manifest discrimination into the AI system, into the model. You have to be really aware of it, and you need, like very often, the best is if you have like a diverse team to see many perspectives. You can address this, but data is always biased, and you have to be aware of it. It's not like the truth, but you can work around it. Yeah. Another misperception is always like bigger is better. So I know companies, before hiring a first data scientist, they bought a Hadoop cluster for a lot of money. And then they hired a data scientist and they said, yeah, we don't really have big data. We don't need the Hadoop cluster for probably 6 figures. We only have a few gigabytes of data. My laptop is just fine. I wouldn't say they're stupid like doing this, but it's like a different thinking, of course. In a production, you first buy the machine and then the people to operate it. You don't hire the people to operate it and then buy the machine. So things are different in IT, and also like if you talk about databases, it's always like, oh, what's the performance? Do you need something bigger? And I think you don't. Just fix it, get something bigger if you run low on resources and not before. And also another misperception in the data space is like data lakes are like reservoirs. It's not clean data, you can just like pull data out. Basically, it's just like a theoretical thought concept. So a data lake basically consists of many different systems who just like have a unified API. But building a system on a legacy system of a company is a real challenge. We see the banks in Germany are really struggling. They are over-regulated, and they have really old systems running for 40 years, which is like quite impressive to have like this old system running like this, but it's also like slowing them down because it's not like a startup. As a startup, you can just like take the latest tech. Likely it's open source. You don't even have to invest. You just have to invest in people and your company and the marketing, and you don't even have to invest in the software and pay a lot of money to a software vendor to make things happen. So of course, building something new is always easier than keeping a ship going. And as we see, like data again, access to data is. If I talk to people, data access is one of the biggest challenges for them. So also very often, because there's so much noise on LinkedIn, and I remember there were like there was like this artificial intelligence TV news show in China, and it was just launched, and people were cheering on LinkedIn. Everybody was praising it, and I couldn't help to comment actually. Shouldn't it actually look how it actually works in production before we praise it? Like just being invented an idea and somebody put it out there is not a proof it's actually working. I think it's a very similar experience with the speech assistant we've seen earlier, because also like Siri sucks. I don't use Siri. I use Siri, turn on the lights, play music, nothing complicated. Sometimes you see fancy demos and people say, yes, you can sell insurances with Alexa. I said, okay, this is like a really painful process. It's quite complicated to do all this talking. We saw this. Like, I mean, like clicking on a UI would have been like taken you a minute and you talk, and even if everything's working, like, of course, voice is great, but voice is not the only solution. We will still touch and feel and have buttons and things because it's more effective. For example, like this is one nice misperception as well. Like in 2014, soon we'll have self-driving cars. Everybody said, I expect if you talk to people building cars, they said, oh, never. And I said, no, it's all like Silicon Valley, it's Apple, all these great companies, they're moving in space, oh my God. And I just Googled it, and I think this basically says 2 years until self-driving cars are on the road. It's Elon Musk, right? And I just took the screenshot like 2 weeks ago. No further comment. Of course, things are moving, but we shouldn't expect everything will turn over overnight. It's different than with social media. Social media, for example, it's only software and a network. And once we move into a physical space, the challenges are way more complicated. So another thing is data is not the new oil. This is like the worst comparison ever. Because, for example, oil is oil. There's different qualities, but from oil you can do things. What is data without context? I just give you data. I just give you some numbers without the context. Where is the data from? What's the context? And also, you have to also talk to the domain experts. For example, with colleagues, we were working on a predictive maintenance project. So predictive maintenance, okay, when will the machine break in production, save money, and all this. And of course, there's a lot of sensors involved. But even for specific sensors, you have to talk to the domain experts who know how the sensors work, because there was this one crazy sensor. It was, I think, temperature, and it didn't do anything until it hit a certain threshold. So it was doing nothing, and once it had like 25 degrees, it started to wake up and work. And if you look at this, the visualization, this looks like an outlier. So there's nothing happening, and then you have this peak. And then basically the people who know the sensor says, oh no, this is just like the behavior of the sensor. And you have to, of course, deal with these things as well. But just seeing the data would draw a completely false conclusion. And so it's more like the new nuclear power without the waste, I'd say. So James Brittle is very right here. There's also like these dystopias, like the singularities coming. Ray Kurzweil is a very prominent figure, but maybe read it later in the slides. There's another expert for decades. She says it's not really happening. It's a little bit more complex if you look at it. And of course, this is all the marketing bingo. We've seen these. I couldn't help myself to comment this Siemens careers. So look at Uli. Uli is teaching machines to think. Yeah. This is a marketing video because they're recruiting, and I couldn't help myself. I mean, it's just like a stupid marketing tweet, but it's always like, I said, okay, so I wrote, machines don't think. Maybe Uli wants to tell his colleagues in the marketing department. And actually, Uli replied and said, yes, you're right. Yeah, so... And many people say, yeah, we've all seen this before. It's just a hype. Yes, they're true. It's true. MIT Technology Review. So I think everybody knows the MIT. It's like one of the best, if not the best, engineering university in the world in Boston. It said people who emerited from MIT, if you take all the people who started at MIT, is the 6th largest economy in the world. So they're a big innovation driver in tech. And there's MIT Technology Review, their magazine, and the archive goes back until the 1900s. And as having a subscription, I just found these on the way while going through. So can computers create literature? It's a thing from the 90s. We just heard about this, computers writing articles, beyond artificial intelligence, how to keep mature industries innovative. It's also like in the 80s. The automation, you see like the robot arm against the worker in the middle of the 80s. Women in technologies in the 1984 is already a thing. And also like this, I like a lot, it was just like in 1986, after 25 years, will artificial intelligence ever fulfill its promise? So all these topics we think are pretty new, and we're facing something very new. Yeah, actually it all happened somewhere, if you look into it. And I suggest you do, because it can be instructive, and because not reinventing the wheel. Last year, I had the pleasure to see Kasparov giving a keynote. So who is Kasparov? Kasparov is this is him in the 90s as well. Kasparov was the brain's last stand. He was the world champion in chess. And at that time, IBM had built Big Blue and a supercomputer, or I think Watson, it was the research Watson, and he played against chess. Like the same thing we have with DeepMind playing Go now. So, and it was basically a brain lost hand because many smart people here who were invented the technology or like Turing, like the theoretical backgrounds, they said, once the machine is able to beat the human in chess, they have superseded us because chess is just like so imaginably hard. But I mean, what happened? It was like 20 years ago, so yeah, probably it's different. Actually, it was quite nice to see Kasparov. He was pretty relaxed, basically. I mean, like chess computers. He was beaten by computers. So was he jobless? No, he wasn't. Here you see basically like he was basically the Magnus Carlsen of his time, and here you see like the chess player ratings, and you see AlphaZero is like already like a lot better than any of the chess players. Do people stop playing chess, or is it now worthless because the computer can do better? Also, he thought about like there were new concepts. How can the computer help finding new strategies in chess? And so it's open interest in chess. Now we see it with Go. This is 2016. This is the world-class Go player who lost 4 rounds against AlphaGo. So have machines superseded us? No, it's still just like a game. And of course, this game is a lot about computation, strategies, and options to move. And computers are faster, and also computers can scale this. You can scale these calculations horizontally in the cloud. So, and we have only one brain, so it's actually it's not a fair fight as well because we are not built like that. And you see, like these, this is how AlphaGo. The thing with AlphaGo was AlphaGo self-taught. Nobody implemented any rules, or it was not provided any data how a Go is actually played. So it figured it all out. So the rules were actually implemented, but it learned really fast how to learn Go by itself. It also came up with some new strategies it discovered on the way. So it's amazing technology, but still, we're still there, and happened 3 years ago. And I think this is like the best citations here, and I think this is something you should really think and resonate about. It's from Pablo Picasso. Computers are useless because they only can give you the answers. It takes maybe some time until you get a better grasp of it. So, because it's about questions. So, let me give you some demos and magic. Some parts we also do with people. So, for example, there's certain approaches how to tell people who are not in the technology yet to understand it. So this is a company we work with from the Netherlands. They have invented a board game where you have different stakeholders, and they basically have to play this game, and then they understand the whole process, how to implement a machine learning or AI project better, so everybody's on the table and understands the role, the process, and the benefits. This is something very often skipped because who has heard about the Titanic example? Yeah, if you go, it's like the beginner's thing. But we are probably like super bored because I've seen it like 100 times. But if you bring somebody to the space, I think it's very instructive still because everybody has an understanding about the survivors, why they survived. It's like common knowledge what happened and why people survive. So it's totally okay to present stuff. You are probably personally bored already to explain other people's the technology. Yeah, we already covered that, so probably not. Sharing anonymized data without access to the domain experts, yeah, good luck. There's also like a lot of noise on new findings. If you read blog posts, very often it hits also the news. You see, yeah, there's some researchers have found this, and there's a lot of noise, of course. And I think this is great because like these papers demonstrate impressive findings. So following the progress is like very, very important. But we also have to see 95% of these papers, unfortunately, do not work in production as well. So a lot of work, and following is important. And I love how open and fast research and research results travel nowadays. So that's the upside. And also, if you look into deep learning, it's probably not the universal problem solver. You still have regressions. So there's like 2 great talks about it, how to better reason about what is the right technology to solve the problem. And it's not deep learning for everything, because maybe people thought, oh yeah, deep learning is now better than machine learning because it's neural networks, complex, it's more intelligent, and likely it's not. Let me introduce you to one simple neural network. It's easier to understand. It's a CNN. It's actually like mimicking how we perceive visuals. It's also used a lot in visualization. Here you see we basically pick information here, take the most important part, and just process this to multiple layers. And it's like big. The fully connected network at the end. So basically, first we filter data, and we basically filter for the most important or the highest signals, for example, in a picture. And then we put the data in, and it's actually, the data is all matrices here. It's all matrix calculations. It's all linear algebra. It's not high sophisticated mathematics. It's just linear algebra. And here you see, which is the network starts to store information. So, for example, if like this, what we call neuron here, it basically gives you a high probability value once you see like a structure like this in the picture. And then we have like a lot of like output values, and then you have like multiple layers, and basically you can also say like this is just like a complex correlation network, like having like multiple input signals, and it will give you some predictions. This is very likely, like probably 95% this is a woman, it's probably 5% this is a man, and 1% this is a cat, or something like that. This is how it works. It's actually no magic at all. It's just like a lot of data, a lot of matrices, and we're just not able to actually get a grasp on it, because we think 3-dimensional. We don't think like in 100 or 1,000 dimensions as we can do with linear algebra. These are like some things we can do. We can denoise corrupted data, because we actually know how the shapes in the world look like, and so we can basically reconstruct this. We can even like reconstruct parts of a picture or remove text here. And this was basically one of the first steps I took into the AI space to understand it better, not just like to read about it, like, okay, what's applications? Actually, I stumbled across style transfer. Who has seen this before somewhere on the internet? Okay. So style transfer actually was invented at the University of Tübingen. And basically the idea is, so this is why we see this picture of Tübingen here. The idea is to take a picture of Van Gogh or Munch, and to learn the style, how this picture is painted, apply it to the original input photo, and generate a new painting with a new style. So basically, we train a model on this. This is our input data, and this is the prediction. So, this is the prediction in this case. So, I tried. Okay, let's try this. So, I tried with this because I'm not really the comic fan. I just usually like the covers. So this is a comic I read in the past, and I said, okay, I really like this French style. It's like, it's different. This is like how a modern DC comic looks like from the Flash. And I said, okay, I think this is a little bit more nicer. So I took open source software. I took my computer. I got myself an NVIDIA 1080 GPU. So it was not a big investment, and it's all open source software. And I even was able to jumpstart my project with code I found online. People just shared. So I did not have to study AI and neural networks before actually applying the technology. Basically, you can first play around, apply, and then go deeper to learn about it. And this is, I think, the best approach. So basically, the style is learned on this page. This is a picture we want to change. And this was my very first style transfer, and I was just like, wow. At that time, I also believed, oh, deep learning will solve everything. This is just like so amazing. You just like plug it in, feed a picture in, and you get something like a transfer like this, because this looks very similar to how actually these characters could look in the French comic then. I said, okay, wow. So I was quite impressed. So I applied it to Venice. This is like a picture I took at the museum. And applied and said, hey, this is like awesome. And you can also learn on different styles. This is from another comic here. You can apply it to this picture, or like holiday pictures from Scotland, or to Game of Thrones. And you can even take a whole page of a comic and transfer it into a style. And this is why I always say, okay, be open in the space. It's research and development, because I was just interested how will this look on a very old Flash comic from the 50s or 60s. And I was only able to find like a really blurry picture with like a really small scan. So it's if you look here, it's not like from the back, you cannot really read this here. And if you apply the model here, oh, you can read it. It takes the coloring, you basically you reconstruct the picture like in a different fashion, but we also have everything readable again. This was just like a finding on the way. I trained also a model on this picture, and this is like the input picture now. Like, so you just put white noise in there, so Bildrauschen, ne? And then this is the prediction. And I took this picture, I sent it to some friends, and said, hey, I'm at Tate Modern in London. I just fancy this picture. How do you like it? Hey, that's a great, awesome. This is a great abstract picture, and it's actually like just AI applied to white noise. Yeah, this is like actually how it looks a little bit more in depth, but I think we can skip that. And this is like just like an example movie on how a network is actually learning, because we always feed input data in. And we train and we train and we refeed the same data again. And basically, it's basically like tuning. You can say like it's like tuning thing, because linear algebra, gradients, it's all math. And this is actually how it looks like how a network learns. So this is taken while the network is being trained. We always make a prediction, and the prediction is what you see here. So once again, the tiger picture we know. So we see in the very beginning, really, it picks up really fast, like shapes, and you see like this flickering. These are like the gradients. This is the math, like trying to optimize. The algorithm is trying to optimize, find the lowest loss to produce the best style. And this is like, so you see at the beginning it's moving really fast, and the longer it runs, the slower it will improve the model. So this basically goes like this. So at some point you have to say, okay, it's not getting better, and decide, okay, we have to stop training because will never reach 100% accuracy. We can apply this on different. This is like a picture which works really well on many styles. This is a Möbius comic. This is another variant. This is a Franz Marc picture. So this works really well. And these are also like the examples you will see online, because everybody's cherry picking. Everybody's just writing blog posts, how awesome they are. And I like to point out, not everything works. For example, here we have like it's just people standing on a beach with backlight, and you see like, no matter which style, they don't really work or resonate that well on this picture. And so it's not just like, it doesn't generalize well. Everything does not, sometimes it does not work. So I started a little project. So I was like still like style transfer is great. I was super excited. I was feeling this, and I said, okay, I wanted to do a talk series about deep learning and what we can do, and said, okay, how can I look at deep learning from multiple perspectives? So I came up with my plan to how can I synthesize this? Who knows this? Okay. Not everyone, okay. This drei Fragezeichen, the 3 question marks. 3 investigators, if you don't know, the drei Fragezeichen is like super popular in Germany. It's a radio drama. It's 3 juvenile investigators solving mysteries. It has 200 taped radio dramas, because I had to look into something into the space I can understand. I can understand, because I'm a fan since I'm small. I have all the input. One thing I was looking into was, is it enough sufficient data, like 200 Hörspiele, is that enough already? Basically here, basically background Hörspiele, basically it's radio dramas, very like Orson Welles, but let's skip that. So you have multiple features. You need a cover artwork to put it online to Apple Music or something. We need a story, we need generated text, we need voices and sounds. And these are like the domains to look into. These parts, how far can we get with synthesizing? And imagine I'm still like super pumped with the learning, the style transfer things. So these are the questions to explore. How far can we get with the neural network? What's the data acquisition and processing step? What are the costs? Because we're a consultant, so I have to say, okay, what is the potential? What can I make out of it for my company as well? For a use case to explain things better. So the process is always the same: get data, clean the data, research a paper or working solution, verify it's actually working and not just a claim, adapt the solution for the use case and maximize the quality. And so we know about images, so I started with the images. So the task here is fabricate artwork which looks like drei Fragezeichen. And half of them are generated, half of them are real. Who is the biggest fan? One. Okay, of course, this is fake. There's Seltsame Wecker, that's a classic. But basically, these are the fake ones, and these are the real ones. So you see, you can get pretty close. I said, okay, yeah, great. Let's look into text. How can I generate text? And there's this great blog post from Andrew Karpathy. He's now the chief data scientist of Tesla. And he wrote this blog post, and he was working on Shakespeare sonnets. And he said, okay, let's feed an AI, an RNN, learning on Shakespeare text data, producing new Shakespeare sonnets. It's a great blog post. So the process is, okay, rockybeach.com provided the fan-made transcripts. So data quality was provided. And actually, we're looking into a corpus of 1.5 million words, and 56,000 are unique. And I just took the data, fed them into an RNN, which we use here. So RNNs are very good for processing sequential data. So basically, it builds a network to see how likely is an A once it was preceded by an H, and it spans like these possibilities quite widely. So it's a technology, for example, for auto-completion if you type something on your phone. So you use it already. So I tried this with the corpus, and it looked like this. Okay, so I put VI in, and I wanted to have a prediction, and this was basically the result. I said, yeah, well, I also did a Google translation of it, which is amazingly accurate, actually. But you see, this looks like German. I could probably sell it to a non-native speaker. This is like, this is German dialect. Yeah, you don't know Schlokolianer, so this is like really fun. But okay, this was a bummer. It didn't work as expected. So I said, okay. I also sent it to friends. Yeah. So they asked. Und dann said, no, so Sprechtirrung, nein, das ist ein neuronales Netz, that's a neural network. And I also read about this chatbot, because chatbots are also like a big thing. And I read about, there's the Star Trek Next Generation chatbot. And this was a very comparable project to what I was working on with the drei Fragezeichen, because somebody fed all the transcripts from Star Trek Next Generation. Star Trek Next Generation has, I think, 7 seasons with like 24 episodes. So you have a decent text corpus, and I said, okay, let's try this. So I even fed something which is actually from Star Trek Next Generation to make it a little bit easier for the AI to respond. So this is actually a sentence from Star Trek Next Generation, but actually all that came out was noise. It was senseless noise. I was very disappointed, and I could say, okay, it's probably not just me, like text generation is a really hard problem. So what's this next thing to look into? So I was a little bit bummer, but I kept, okay, let's pull through. Let's look into synthesizing speech. So we want to generate a human voice and make it sound like a known character. And I came across this. This is the Stackoton-2. So you see this is a little bit more complex neural network, and it actually learns from MEL spectrograms. So what is a spectrogram? A spectrogram is just a representation, a visual representation of sound. So basically, this is just like a fast Fourier transformation, if you heard about it, of a sound wave. But I think it's quite intuitive. What we see here, somebody speaks, and you have like peaks, and these are basically like the different frequencies where we have a signal. And I said, well, yes, and then you just feed the text, and you just have input text. So you feed it with snippets, like short audio snippets, and the text, and put it to this network, and then it should learn how to speak, or like to generate a voice once you provide a text. And I was said, yeah, well, the text thing didn't work that well, so I did not have big expectations. So let me show you some results. A big part of this, I was able to have, this was trained on a really nice data set, which is available open source. It provides 24 hours of audio read by one person from non-fictional thing. And let me show you 3 examples how the model now basically reads this sentence. Oh, we don't have sound. So, just a second. Let me fix the sound. Sorry. Yeah. So, okay, let's go back.
Why it's a poem lives I've been amazingly sorry. Although it is got a bit more into the facts. I've been native to the buildings have a.
Oh no, actually it's already 14 hours. It's like it has got one here. So, okay, it's not too bad. And after training of 9 days, and remember, this is trained on a single GPU, which is like $800 in the store and open source software. This is like a peanuts investment.
Once upon a time there was a little mermaid named Siren who lived with her stepmother under the sea. She didn't get to go out of the sea like any other.
So I was pretty impressed and surprised this works this well. And I think it's a very nice example how powerful AI and architectures can be. So I also tried it in German. So I've actually, to sum it up, 9 days of training. So it can now read me any English text. This is basically a project with not a huge budget. So yeah, so I can scale it. I can have my own cloud service with this voice. This is basically the equipment. So this is like pretty impressive. How are we with the time? Oh, we're over time. So let me speed it up. Okay. So the XJ2 number here is like high quality data and a collaboratively designed neural network can produce impressive results as well. So let's do it in German. Yeah, we did it in German. So yeah. So there was no open data set. So we built a system with heuristics, and let me just like play it.
Deutschland kein das heißt, das ist übel,
This is basically early stage learning, but this data set is not as clean. It was semi-automatically cut because actually I asked my partners, hey, can I have like 2 or 3 people for a month to cut audio? And they said, hey, Alex, we really like your talks, but no. And so basically we had to come up with something smart. How can we basically create a data set from existing audio? So actually I scraped site audio and the newspapers, and then with some heuristics and signals and translation service, it was...
Deutschland hat keinen Tag vergolden, heißt es immer wieder. Wir neigen unseren Schülern die Angebote für die besonders Talentierten.
So actually it's not that bad, and also you even can... The original speaker who read these newspaper articles, you still can hear and see this is actually the person. It's not just like a made-up voice. Actually, it sounds quite like his voice. Of course, it's still cranky, I think. So actually, let's skip that. Of course, like the whole.
Maybe we should open it up to Q&A.
Yes, yeah. I'll just wrap it up, and then we can do some Q&A here. So also meanwhile, while working on this project, this is another challenge in every project in this space nowadays. You have to be open to totally start with a new technology, because there's so much new technologies invented in this space that you cannot just like settle for this for a project and say, okay, this is the only network we're going to use for the next year. You always have to see, is there something better, and be like super agile in the decision process as well. It's not hard. Yeah. Let's skip that. So you can also like attack neural networks. This is YOLO. Basically, YOLO identifies persons. You see, just like this other person has like this picture, and the neural net is not able to identify him as a person. This is a big challenge. So you cannot just like have autonomous cars like reading signs, because you can have like feed signals, put stickers on them, and the neural net will fail. Actually, this is my best. This is the funny part. Hello, I'm a person. Yeah. So you can also generate data from networks. It's like use cases. You can switch zebras with horses. You can have summer and winter. One thing, this is from research, this is like small pictures. You have to see, like, this is not a picture you take with your iPhone with like 4K for MP. This is like small pictures, like 256 in research papers. Very often, nobody writes about this. And you can also apply it to other things. It's not always working. I really like, actually, the authors of the paper put this in the paper. It was not only about cherry picking, they also put this in there. This is another impressive example. These persons are all generated by an AI, a GAN, which was built by NVIDIA. Of course, they have a lot of power. So they were just like, none of these persons actually exist. So is this the end? It's like a little bit of deepfake. But if you look a little bit closer, there's still like tons of artifacts. You see, like, this is a woman being like a model, and there's a lot of like noise there. So let's wrap it up. Okay, this is the final one. This is my final example. So there's like this. This is a classic. Let Google translate Ak from Somali to English. Short play. Oh, no. It's a little, yeah. So you can have like Ak, and you always see like this is the translation, Ak Somali, and yeah, you see, I think it's a very good example to see how a network like are trained, how they work, how they fail. It's actually quite funny. Yeah, because it also contradicts itself the more acts you put there, and once it settles for something. And also, like, if you do this multiple times, sometimes you get different results as well, because this is just like a network trying to react to this data. Yeah. So, okay. You can also like put chickens in there, and the network will predict with 99% it's a 5, because neural networks do not perceive reality as we do. It's only matrices. This is also like a really nice example. This is a panda, so the network is the confidence is like 57%. This is a panda, and then you put like just like pink noise in here. So this is just like some color signals we don't see in this picture as humans, but of course it's data in this other picture, and now it's 99% sure it's a given. So of course, these are like attacks. You have to know these attacks. You also have to explain everybody, for example, at clients, you also have to explain neural networks also store your data. So there are attacking models where you basically can draw business information by re-engineering the signals you get back or the predictions you get from the neural net, because it stores data. Making AI happen. This is again here outside. When the last time the Avengers movie was shot here, I think the most important thing how to make AI work is actually to team up. So everybody in the team has to be open, honest, and respectful. You need to build like a very good communication culture where everybody is like focusing on where they are best at. It can be stakeholder management, it can be talking to people, it can be tech, it can be data engineering, it can be super high-level math, like inventing new networks or whatever. So everybody has to basically work together. Also, like the people who have the knowledge. For example, like apart from we do this in our company, we are also part of this network. It's PyData. It's PyData. It is an expert network in 51 countries. With I think now it's like more than 150 groups, and there's like 140,000 people in there. There's also a YouTube channel with a lot of videos. So from the conferences and meetups, we share the videos where the experts share knowledge and expertise. We run 2 chapters. We run PyData Frankfurt here, where we have expert talks on, for example, like this was a really interesting talk about like product classification at billiger.de, which is a leading company for recommendations for buying online. For example, in Frankfurt, we run this with KPMG, and for example, this is so it's a community where you can ask questions, be open about it, and share. We also do it in Südwest, which is Heidelberg, Karlsruhe, and Mannheim. Heidelberg and Karlsruhe have also excellent universities, and we build a great community there. And for us, it's very important to get in contact with experts we hire for projects, or also like working students. Basically, we don't have job posts out there. They just come to us and say, hey, we like how you are at the meetups in the community, so we're just being ourselves, and people say, hey, this is great. Of course, there's also like the conference in Berlin. We're like a 4th year in a row community sponsor. So this is like a big gathering of 1,111 people this year. Let's move to the Q&A, because I hope you enjoyed it. I hope you learned a little bit more about the different aspects of AI. And yeah.